Hello, 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 everybody. Morning, good evening, wherever you are in the world. It's bonfire night here, so apologies in advance for fireworks that are going to go off during today's session, but I hope you're all doing well. If you want to just throw a hi in the chat, just so I know the chat is all working. I think the chat. 1 second, folks. Right, don't worry, we'll get the chat fixed up here. But in the meantime, welcome to today's webinar. My name is Katie, and I will be the webinaring today. Okay, cool. You should all be able to chat now, so feel free to throw a little hi in the chat. There we go. So welcome everybody to the API Masterclass. You might be thinking, wow, this seems really similar to the other API Masterclass. It's the same webinar series. So this is for folks who missed out the first time around or didn't get to go to every session live, or maybe the time zone wasn't great for them. So hopefully you can all kind of experience kind of like a live class. So participation is required today. We are going to be using Mentimeter and doing stuff together. And you'll be able to like interact with the slides, and hopefully we'll all come together here. So if I just share my screen. There we go. So there's going to be a QR code here. This is the Mentimeter QR code. If you don't trust QR codes, don't worry. The code is just up here. And I am going to send this to everybody so you can participate should you want to participate. So welcome to the API Masterclass. This is a series of 6 webinars in a series which takes you from knowing absolutely nothing about APIs to learning about API hacking, to learning about defending APIs, how to do a SOC for APIs, and how to actually end up running an API security program, and kind of what it's almost like I guide your hand through all of API security. So if you don't know who I am, my name is Katie. I am technical marketing at Traceable, which basically means that I know absolutely nothing about marketing. I am a technical person. I'm an API hacker. As you can see, I've got all these little posters up here in my office. These are all from various live hacking events that I've participated in. Of course, I have the Union Jack because I'm very patriotic. So welcome to today's webinar. And today we're going to be covering what an API is and kind of why they're so hard to secure and why developers kind of struggle, and kind of answering that question of why are APIs so vulnerable? Why is it so hard to build good APIs? So here are the Mentimeter instructions. You can use the QR code, or you can just go to the website and enter the code. That's going to give you a version of the slides like on your mobile device. But when I have interactive elements, it's going to enable you to interact with them. So let's start with the first interactive element. Share where you're from. I know a few people are doing it in the chat already, but share kind of where you're from. You should just be able to tap on the image, whereabouts in the world you're from. You know, within reason of some Americans. Happy Election Day, Americans. Hope your voting all goes well today. Some folks in Spain, we love to see it. India, of course, always India. You guys always come to these, and I'm always amazed because it's a terrible time for you. Oh man, Central America. Okay, that's cool. I don't know if we've had someone from Central America yet. And where's that gonna? It's probably not South Africa, right? Florida, Raleigh, North Carolina. I've got a friend in Raleigh. Washington, D.C. Wow, you guys are really in it in D.C. I saw some videos today of like some shops that have already been boarded up in DC. Up in Maine, my friend went to Maine like last week and he loves it. I have lots of friends. I have to come visit because like I've got a friend based there and he brought me a Venus flytrap t-shirt because I love Venus flytraps. So and I have like a few and he bought me some. Cool. So hopefully that kind of teaches you like how the sort of Mentimeter stuff is going to work. We've got a little quiz and it'll hopefully be a little fun. So I want you to have a think about how you would rate yourself. So if I ask you how experienced are you with how APIs work, where would you put yourself? Like, are you more on the beginner side or are you more on the advanced side? How APIs are made, so how developers actually produce and deploy APIs, how to secure APIs, so on the defense side, and then how to hack APIs on the kind of attacking side. This just gives me an idea of like who's in the audience, so I can kind of adjust it based on what your like skill levels are and what you feel good at. So a lot of people kind of new to API security, but most of you know how APIs work. That's really good to hear because APIs power everything. Like, no joke, you will use these every single day. You probably don't even realize it. I mean, today I controlled, like when I was setting up for the webinar, I turned on my video lights, and that's of course using an API. Of course it's an API. Everything's an API. So I think it's good that people are aware of it, but I can see everybody like is kind of more on the when it comes to the security and the hacking side, are a little bit more beginner. But it's totally fine because this is definitely where you want to be to learn about API security. So what is an API? So APIs are a type of application not designed to be used by humans. It's not like an app where you interact with it directly. Instead, they're meant to be consumed by other applications. They're definitely applications for computers. Kind of like a waiter in the restaurant, it serves as an API between the client, the customer, and the kitchen, the server. So the API will relay requests from the client to the server. They take your order, they'll give it to the kitchen will make it, they'll come back once it's cooked, etc. And when we talk about API security, particularly at Traceable, we're mainly referring to web APIs. Now, the APIs can exist anywhere. You might have heard of Windows APIs, for example. They're very different to what we're going to be talking about today. But generally, where people say APIs, they mean web APIs unless they like say specifically. And these are really the building blocks of all modern technology, whether or not that's microservices where you can switch things off and on, you can swap out components, whether or not that's big monolithic APIs that power mobile apps, whether that's something like GraphQL that allows developers to be flexible. And all these different ways of doing APIs presents a huge challenge security-wise, because when an API can be essentially anything, how do we manage to secure that? There's a few reasons why developers really like to use APIs, and some of them are things like they can write an API once and use it in lots of different places, so it reduces their development time. It allows them to be a bit more efficient. So things like if they've got a mobile app and a desktop app, they can make an API that's shared among both of them, and then they don't need to hire like another developer. They can kind of be a bit more efficient with how they spend their time. APIs are very standardized. There are ways of doing things and they are quite prescriptive. So you don't have to think too much about the structure element of an API. Instead, you can kind of just choose your favorite standard and follow it. APIs are built into most programming languages now. Certainly there's a library to do it. If you're using a framework, it's probably already built for you. You just need to switch it on. And what that means is from a developer standpoint, they don't need to think about how to build an API. It's kind of already there. Like, they're not having to code anything in particular. APIs have really wide support. Every single programming language has an API and is compatible with APIs, can make API requests, can send or receive API responses back and do something with it. And even if it's not like a default feature, there's definitely a library for literally every programming language. They're so widely used. Developers really like the ease of integration of a lot of APIs. So with a lot of kind of especially newer startups, they'll build an API to get users on board. They'll build an API that, say, third parties can use, things like Twitter or Reddit, who have famously in the past 2 years said that they're charging for their API usage now when it used to be free. And it can be a great way to get users on board, to build integrations. If you're familiar with If This Then That, all built on APIs. Literally, it's all APIs. It looks like little building blocks. It's APIs. APIs are scalable. So companies can start out by having an API that maybe doesn't get a lot of traffic, but as their organization grows, their API can grow with them, both in scale and like number of endpoints. It can scale as their features of a product increase. It can scale with resources. They're very simple applications. It's not going to require too much work to get something to scale. And finally, developers like APIs because they are friendly for developers. For a developer, it makes it really easy to build, to make stuff available. There's tons of like help available. If you Google like RESTful API and an error message, you're going to get a response. And for a developer, that can be huge because, again, it's something they're familiar with, but it's also something that's very standardized. There is an answer. So in order to speak to APIs, you need to know their language. So there are two different kind of responses or two different ways you can request data and receive data from an API. And those are XML and JSON. Both of them attempt to turn complex objects into raw text. So a JSON will use a series of objects denoted by these little curly brackets here. Little curly brackets here. And then they have a key value pair. So this is the object, and this has the ID of 1, has the name of Leanne, has the username Brett, and has the email whatever, right? That is one single record. Then ID 2, this is another record. Now, XML is very similar, except for it obviously uses something that looks very similar to like HTML, where you, again, have key value pairs, but you also have parameters or variables as well. So here we've got employee data, employee ID is like in this kind of opening tag here. These are just more like key value pairs. Both of them are really flexible, but especially XML. JSON is a little bit less flexible, though saying that it's just raw text, right? Now, XML is far more common when it comes to your like SOAP APIs or like older API types. JSON tends to be what you see most often. So this JSON here, this is what you're going to see the most often, especially nowadays, because this tends to be how APIs are written. So why do they use separate languages like this? So APIs are fundamentally designed by and for programmers, for developers. And XML and JSON represent the objects in them. So if we think about having a car here, we can start to represent this idea of a car having a model, price, color, and year of build. And we can see this car here is the model, AAA, price is 10K, color orange, build, year 2015, and we can represent that in JSON really well. Now, if you already know something about developing, you might be familiar with this idea. It's called serialization. So when we take an object and we turn it into text, that's serialization. And then we take it back the other way, that's deserialization. If you're familiar with some vulnerabilities, you might be familiar with things like Java deserialization vulnerabilities. This is the process of turning an object or a complex object represented in computer memory into a piece of text and then pulling it out. So in order to create these, they essentially just use libraries. I mean, this is very much something that is done automatically by developers. They don't have to think about how they're going to represent that in JSON. They just have to enable a setting. So again, this is really just about turning those complex objects into very simple pieces of text. Now, these are not the only types of APIs. API is a general term, and we are not going to be talking about this kind of API. So it's used a lot in the terms of operating systems. So Windows API is referring to the operating functions in Windows, things like drivers, things like whatever, like printing, that kind of thing. Not the kind of APIs we're talking about. We're talking about web-based APIs. So you might already be familiar with quite a lot of use cases for APIs. Any single time you've used a third-party integration, I mean, maybe you use Zoom to log into this webinar, and maybe you logged into your Gmail account and logged into Zoom through that, or your single sign-on, or maybe you got a calendar alert telling you to come here. That's all APIs. You might be familiar with developer APIs. These are APIs that are intentionally exposed for third parties to essentially build integrations off of, whether or not that's something that is free or paid. Things like, if you want to use ChatGPT, you can use the OpenAI API. It's all APIs all the way down. And finally, APIs are often used to give some separation between different components. And this is because when a company is building software, they don't want to take everything down to update it. They want to be able to update select areas at once. So like, we're going to focus on this, or we're going to focus on that, etc. So we just need to take down, say, the payment system. We don't need to kill the entire website. We're just going to say, you know what, you can't make payments via PayPal today or whatever. You might already be familiar with Open API specifications and Swagger. So Open API specs are a way for developers to kind of standardize what their API does and be able to share that with others. So this is an example of a Swagger file. It's got some information about the API itself. So here you can see these are the paths in this API or endpoints, and you can see this get, you can see like listing, and this responds to this part here. And essentially these allow you to share what the API does and how people can use it. Really common to see these. Swagger is just a visual like IDE that you can use on an API. You'll see them quite a lot. Not every API is going to have them, and not every API needs them. So the way APIs work, no matter what type of web API you're dealing with, is often about CRUD and resources. So everything that is kind of a database table in an application is a resource. If you think about the functionality of something like Zoom webinars, you all have accounts. You might belong to an organization. You might belong to, or like this is a webinar, you have chat messages. All of those will be considered resources in the API. And a resource is anything that can be CRUDed. So things you can create. So create a new account. You can read, so you can read account details. Update, you can update your own account with new information if you change your email or something. And you can delete your account. And you'll hear these terms a lot, like this idea of CRUD, and I'm going to be using it a lot. CRUD is kind of like the lowest thing you can do with an API. It kind of describes everything you can do with a single resource. You'll also hear the term API. That usually refers to a collection of endpoints. Endpoints are simply URLs that do something, that don't return like a 404 error. And usually there'll be 4 endpoints representing create, read, update, delete. Finally, you have the idea of routes and routing. This comes from the developer side, and this is how developers think about their code. So depending on what language the developer uses, the idea of what a route is can change. But in general, a route is the same as an endpoint. So if you think about typical APIs, think about Twitter, you can log into Twitter. So you have a user resource, you have a tweet resource, you have a like resource, like all of that comes together to form the API. So there's a bunch of different ways that somebody can design APIs. And there are these different kind of philosophies around it. So first you have RESTful APIs. These are by far the most common APIs. 90% of every API is going to be a RESTful API. They have a very distinct structure. They were created based on this guy's PhD thesis, where he had this whole philosophy about how API should be developed that developers saw, immediately ignored, and then did something else with. You've got RPC, remote procedure call. These are APIs that control usually physical objects, things like webcams, things like switches, things like light bulbs. And instead of an API kind of dealing with resources, it's about what processes that API controls. You have GraphQL, which is about kind of creating more flexible APIs, very new way of making APIs. Definitely like 5% of APIs will be GraphQL. Definitely gaining some steam though, because of its more flexible nature, and certainly becoming more and more popular. Webhooks. This allows you to trigger APIs on events occurring. So when you get a notification, then kind of APIs. And then SOAP is the old man. That's really how we used to build APIs. They tend to exist a lot in legacy systems. This is where you're going to get your other 5% of all APIs. Now, in order to see APIs, you can use a tool called Postman. I'm not going to spend too long talking about Postman. You certainly don't need to learn how it works. To do any kind of API security, to be honest, you can just use like regular text. However, the collections, being able to kind of start to document it, and certainly if you work at a company where you are like defending a lot of APIs, your developers are probably already using Postman. So the more you can integrate into how they already work, the better, really. Plus, it saves you a lot of configuration as well because they already have that stuff enabled. Now, APIs are very specific to a task they're working on. Their architecture is very dependent on that task and how it works, and developers will pick and choose what API works for what they want. RESTful tends to be the default, with SOAP being the kind of older design that's been replaced by RESTful, and GraphQL is the newer design. However, every different like API has their own use case and reason to be used. And certainly you can't just say that's a SOAP API, so it doesn't matter security-wise. If it's dealing with real data, it matters, even if it's old. Plus, it's not always, and it's a very junior thing to do, by the way, as well, to immediately suggest ripping out legacy software without really understanding like how deeply embedded it might be in like existing processes. So certainly when it comes to APIs, they exist for a reason, and it's important to respect that reason when it comes to like handling developers and being like part of their team. Okay, so let's talk about API types. So the most common API is a RESTful API. It follows this very clearly defined structure. And once I tell you it, you'll see them everywhere because they really do exist everywhere. So RESTful APIs have a different endpoint for every single CRUD functionality for every single resource. So if you want to see all the blogs, if you want to see one of the blogs, that's our read. If you want to create a new blog, that's our create. If you want to update a blog, that's our update, and our delete. Destroy a blog, that is our delete. Now, these use different HTTP verbs. So any single time you're retrieving data, that's a get. You're sending data, like creating, that's a post. Updating is put, and destroying is delete. Now, this structure exists everywhere. The more resources you have, the more endpoints you have, the more the larger your API becomes over time. So as your software increases in complexity, you have different resources, you have even more integrations there. Now, RESTful is definitely the default, like 100%. It is used in production everywhere. There's lots of support in lots of different languages, lots of different frameworks, lots of different tools that support it. It's the well-established, the tried and tested, the build with boring option. Developers know how to build them. They mostly know how to secure them within reason. And they're certainly the most common one you'll see. 90% of all APIs that you will see will be RESTful APIs. They are everywhere. RPC, remote procedure calls. Now, remote procedure calls have a different API use case. So they are used when, instead of like interacting with objects or resources, instead you are telling a server or telling something, hey, I need you to run this process. Very, very common in things like Internet of Things, where you don't really care about the states of objects. You just care that they are doing something, switch on that light, start recording, stop recording, send that. But this is the kind of more function-oriented API, if you like. It's all about functions rather than CRUD. So while RESTful APIs are handling objects and like CRUD, creating, reading, update, deleting objects, RPC is very, very functional. You are calling a specific function on a server with specific parameters, especially in cases where you've got low-powered devices where you don't need a full API, and it would kind of be a waste of processing if you did. RPC kind of steps in to be very, very lightweight and just provides like a standardization for, hey, I just want to call a function that this thing can do. Now, the one you may have heard of the most is gRPC, which is Google's modern kind of open source RPC, but there are actually a ton of implementations of this. And really, all it's saying is, hey, this API does something, and I don't need much else than that. Now, there are proto buffs as well when it comes to gRPC. It's not really too important to understand them like at a surface level, but just know that they exist. And one of the things that makes especially RPC APIs very, very overwhelming for a lot of people to try and handle is the fact that the proto buffs can be very scary to deal with. Really, all it does is just define the objects that a gRPC API handles, that's all. So GraphQL was created by Facebook, and it's kind of created in very much in response to REST. So in REST, it's very easy for your API to become completely overwhelmed because you have tons of resources. You've got at least 4 endpoints for every single resource. even if you don't necessarily need it, you probably still have the endpoints existing. And what that means is that, especially for large enterprise software, an API explodes in complexity. There may be hundreds of resources, thousands of endpoints. And at that kind of scale, actually maintaining that API from like a development standpoint, not even talking about security, just from a developer standpoint, is so difficult. So really GraphQL kind of comes in contrast to that. So in GraphQL, you write queries. If you're familiar with SQL, same kind of idea. They're not exactly SQL queries, but the idea is that developers pre-write queries. They kind of switch on every single parameter or field that you can access, and then they expose one single endpoint / GraphQL, which then has, you can request what you want. So you can say, hey, I want to grab the user with this user ID. And from that, I want to grab the ID, name, the profile picture, the friend connection. And then it will say, hey, okay, here's the response. If you remove the word, like the ID here, you will not get this line. The idea is that it's very flexible. You can do a lot here. You don't have to worry so much about what's being made available, particularly if you make changes to a API. You don't need to worry so much. Now you can tell a GraphQL, usually because of the word mutations. So GraphQL has queries, these fetch data, and mutations, these change data. So they might delete something, they might update something, they might create something, but queries will always just read. So it's a little bit more simplified as well. The general philosophy of these APIs is very much flexibility. If your API response needs another field, you can just specify it. It allows people developing or developers to only really get the data they need when it comes to the API, except for when an API hacker kind of comes along. And there's a feature of it called introspection. Now, I stress this is a feature of GraphQL. It's not a security vulnerability for introspection to be enabled. Now, introspection allows you to not just query the API and what endpoints and what features it or what functionality it has, but also about the API itself. So you can actually get things like the list of queries, the list of parameters, the list of endpoints, the list of fields. And then that allows you to figure out what data types you need, even if you don't have like proper documentation for that GraphQL API. And I have already seen the question in the comments about what to do if introspection is disabled. One, I wish people wouldn't think introspection being switched on is a security vulnerability in on itself, because it's not. And a lot of people switch introspection off and think their GraphQL API is now secure. It is a feature of GraphQL. It is designed that way. It's not a security vulnerability. But if you don't have introspection enabled and you want to do like security testing and you want to figure out what queries are there, you have to just figure that out yourself, the same way you would for something like a RESTful API. Yeah, you're missing the built-in documentation that is really helpful to have, but certainly not like a requirement. Now, I'm not going to go too much into introspection here, but this is kind of the result. This uses something called GraphQL Voyager, which makes everything look very pretty. But here you can see this is one of the objects. This is a shop object, and this is all the fields that you can get from this shop. So you can see we've got a name, which is a string. We've got a description, but then we also have these connections here: article, blog, payment settings. These are then separate objects. So if you go to payment settings, you can see we've got payment settings here, and that has a bunch of fields on it. This is where the graph part of GraphQL comes together, because you have a very interconnected graph of different types of objects. Now, again, introspection is sometimes disabled, and it being enabled is not a security vulnerability, it's a feature. If that is the case, you just have to test the API manually. Webhooks. So webhooks are about triggering something when something happens. So the idea is that when you use webhooks, you've created some API usually, which essentially takes a request after an event is fired. So let's say you are, I don't know, you're running a messaging app. When somebody sends a message, you want to turn that into something else. A webhook on this can be really helpful because that will turn your whatever into a request with a payload, which you can then deal with separately. So essentially it allows you to build things like notification system, it allows you to build more in-depth integrations, it allows you to put everything together. SOAP. So SOAP uses an envelope structure. So you can usually tell it because it starts with SOAP env and it says envelope, then it has a header and a body. The header tells you information about the API response, and the body contains the actual result of whatever you've done. So here you can see that this has some kind of ID, and down here it's got like set parameter values, a parameter list, parameter key, etc. Again, this is really common for older APIs, very enterprisey APIs as well. Though certainly they are still quite common because all enterprise software kind of is still common. And you can really tell it apart because of its use of XML. Now, while you can see XML in something like a RESTful API, it's less likely. And SOAP, because it replaced RESTful, tends to be a bit everywhere. There's not one type of API that's really common for. Batched APIs. So batched APIs are APIs that contain other APIs. The idea is that especially when it comes to mobile apps, that you may have a mobile app that you need to make multiple requests via the mobile app. Now, you could do that as individual API requests, but that's not very efficient, especially when it comes to using up your phone's battery. So instead, what a lot of applications do, this example here is PayPal, they will put together they'll kind of wrap a bunch of API requests together. So here you can see the body of this API request has operations, and then it has a method, path, headers, the body, the other information, then down here it has the next one. The idea being is that you're kind of wrapping all of these together. You're like turning a single API into multiple, like instead of having multiple requests, you turn it into just one. Sorry. Okay, right, quiz time. So if you have not joined, you can join here. I'm going to stick it in the chat, or you can scan the QR code, or you can just go to this on your phone. Now, this will put you into the little quiz, hopefully. So I'm just going to, yeah, I think you should be good here. So if you could just do a thumbs up, you'll have like a little button on your screen to do a thumbs up when you are ready. That would be really helpful. I think I saw 28 people before, so I'm going to wait for like 20-ish people, just because I know some people's probably left. I'm just going to give it a second. So I'm going to give you some APIs, and I want you to tell me what type it is. And there will be like a reveal of the winner. The quicker you answer, the more points you get, if you want. Cool. So here is your first API response. So this is a get to API/search. And this is the response here. So we have some JSON, we have like a language code, search parameters, search results. So have a think, have an idea what kind of API this might be. And if you join the quiz, you should be cool. Right, faster you answer, the more points you get. So you should have options on your devices. Now you just select which one you think it is. So we saw the API before, it was get API search, and it had a bunch of JSON. We saw a lot of JSON objects. But what kind of API was it? Yeah, good job. Yes, RESTful API. We can tell because it's very highly structured. When we do get slash resource name, we're reading the resources and we got some response back, right? This is API number 2. So this is some XML, and this is a GET request to /QOD, so that's quote of the day.xml. And you can see that we have some response, and then we have a quote. If you respect yourself in stressful situations, it will help you see the positives. Really stunning motivational stuff here. So faster you answer, the more points you get. So have a think about what kind of API you think that was. And you've got 15 seconds to answer. Remember, the faster you answer, the more points you get. And there is like a little thing at the end there. There will be a winner. It will tell us the winner. Oh, yeah. Sorry, I did put this in as a little trick one here. So while it is XML, RESTful APIs actually don't need to be JSON by default. They actually can be SOAP RESTful. They actually can be XML RESTful APIs. Now we can tell it's not SOAP because it doesn't have a body and a header. SOAP always has body, head. It has this nice envelope structure. RESTful APIs don't, because they don't need to. All right, here's our next API example here. So this is a post to localhost 8080 /send outage emails. And then the body of the request is a piece of JSON. So we have a message key that says, we have a scheduled system downtime today at 1 a.m. So again, we've got a post request to localhost 8080 send outage emails. Okay, faster you answer, the more points you get. So your options are on your phones now. So yeah, 15 seconds to answer. The faster you answer, the better points you get, the more points you get. Yeah, it's an RPC API. Now, the reason we can tell it's an RPC API is because it's sending a request to start with. We don't have to like subscribe to a request like we would in webhooks. Instead, we're just sending a single thing, a single function. We're saying, hey, do this one thing and one thing only. When it comes to like RESTful APIs or even GraphQL, it's more about fetching data than sending it. Or doing a specific function. It's more about kind of interaction with like rich objects. So here is another API request here. So this starts with query, example query. We've got some key value pairs here. We've got markets with a parameter called first, and we've got some variables here. We've got borrow rate, cash, collateral factor, and then we've got some other stuff here. The API this is a part of is api.thegraph, subgraphs name, Uniswap version 2. That's the endpoint that you can send this particular request to. So I'm going to make sure everyone... Okay. I will take this opportunity to have a little bit of a drink of water as well. Yep, GraphQL API, super easy to tell because we are making quite a lot of requests for what data we want out of it. It's not JSON because it doesn't have a key value pair system. So we are writing custom queries. So absolutely GraphQL API. So here is another API endpoint. So this API is dataaccess.com/web service server/number conversion. We can see we've got this envelope structure here, and the API is called number $2. So make sure everyone is ready. So answers are on your device. You got 15 seconds to answer. Yep, SOAP API, we can tell because it has an envelope structure. We can see it actually said the word SOAP in there. Super helpful for actually determining the API type. Okay, another API here. So this is a curl request. So this is an API request to SpaceX production. uprailway.app, and it has the data of query. So this is the response here from this API, and this is the request that we're making. So again, answers on your phone for you to get ready to click as soon as possible. People are answering quick as well, like the number goes up so high so quickly. Oh, okay. Big mix here. So it is a GraphQL API. You can tell for this one because if you look, we're only sending it to a single URL here. We're not sending it to like a resource. So you are not seeing /API/users, or in this case /company. But also the other tell here is you see how it says __ type. That is actually a introspection result as well. So fun fact. Right, I think this is the last one off the top of my head. So this API is API instantwebtools.net version 2 passenger, and then we've got some pagination in there as well. So this is the response here. So we've got some total passengers, total pages, and then we've got some data. Yeah, it's a RESTful API. Again, we can tell because it's making that specific request, in this case for passenger information. So here are the results of our little quiz here. So Mike P is our winner with 5,000 points. Really on the quick on the fingers there. So why is API security so challenging? Why is APIs like the bane of AppSec teams? Kind of curious for your responses here. This is just like a free text. You can just type it in. So why do you think that API security is hard? Why do you think that companies really struggle with API security so much? Zombie APIs, yeah, definitely. Shadow APIs, certainly the kind of things that we at Traceable see a lot. I mean, most people, when they come to us, they're like, we have no idea what APIs we have like on our servers at all. Yeah, the responsibility is split. I mean, honestly, when I speak to a lot of companies that struggle, not security teams that struggle with their API security challenges, often there is this real struggle between like development teams and security teams. APIs are very, very developer led. They're based on what developers want, they're based on how developers choose to work. So there's definitely an amount of like, you know, and I in here as well, we've got things like the fact that it changes a lot. Much of the time, developers will make whatever changes they need to an API as often as they like, and they might not even involve security in those decisions. Some other ones I'm seeing here are just a lack of awareness, a lack of understanding. And yeah, I definitely agree with that as well. There's definitely a little bit of a kind of, it's not a black hole. I think developers are really, really comfortable with APIs, but security teams definitely aren't. They kind of see API security as like a special skill, when actually it kind of doesn't change that much from typical AppSec. And I really like Michael's response in the chat as well, which is a lot of business issues aren't easy to secure from an engineering standpoint. It's very much that case of developers will make APIs that work for them, regardless of whether or not it's secure or meet those standards. So here's my summarization of a bunch of problems. Why is API security so hard? They are ubiquitous. APIs are everywhere. They represent such a large attack surface, and a lot of orgs don't even know what APIs they have out there. APIs are very developer led. It's very much run by developers for developers, and they're not involving security teams in decisions that get made. So often security is kind of always playing catch up to developers. It can be really hard to tell if an API vulnerability is legitimate or attacks. In other vulnerabilities, SQL injection, cross-site scripting, they have easy tells on the defense side where you can be like, oh yeah, that person put wherever a tilde, sure, whatever, in that response. They must be trying to exploit something, or there's a script alert one there. A lot of developers assume that their APIs are for internal use only, when actually they're still publicly available. Like, okay, the developers may not be kind of like putting something like the documentation online. That doesn't mean they're actually private though. APIs are deployed all the time in every single like area of the business. They are so frequently deployed and changed. A lot of organizations just lack any kind of documentation. Again, if an API actually like has any documentation, oftentimes they don't. Oftentimes developers may not even remember the API exists. From the attack side, API like security, API hacking doesn't take an advanced amount of expertise. As we'll see throughout this series, API hacking is actually more about thinking through problems than it is about any particular technical skill. And APIs represent a really like unknown attack surface. You don't know what you don't know, and that is the scary part of security. So I'm kind of curious. We did a thing here where we spoke to a bunch of different companies in API security, and we asked them why they thought their APIs were at risk. So I'm really curious where you would rate these. What do you think the biggest reason we found was, the second, and then the third? Or why our respondents, I should say, thought APIs were at risk? Yeah, a lot of agreement there on such a large attack surface, 100%. So this is what our respondents said. Pretty similar. So first is there are security risks because of the expanded attack surface layer, that typical security solutions can't work for APIs. Let's say like a WAF, for example. And the volume of APIs makes it really difficult to prevent attacks. Traceable webinars. Could we share a link to the state of API security report for this year in the chat? Thank you. Because then you can have a look at the data and have a look at yourself. And these have like pretty big consequences for organizations. You know, we have very little policies and procedures. I mean, you'd be lucky to have policies like, so the security team knows when something has been deprecated, for example, that there is any API scanning in place. And even then, API scanning tools, there's not a lot out there. I saw it in the chat as well. What tools can be used to scan for API vulnerabilities? Honestly, a human. So many APIs are about like how the API in the business works. Now, obviously, Traceable, fantastic product. But my like actual answer is it's very hard, and obviously something like Traceable is expensive, and not every security team can afford a dedicated security solution like Traceable. But certainly, yeah, Traceable is good. But there isn't many in like the open source that I found that are like really good. I think AI might lead to some interesting scanners very soon. One of the other more difficult areas of API is like the growing API management. So nowadays, APIs aren't even like created and just exist on servers. A lot of them will get managed through something like Azure, Kong, whatever. And that provides like another layer for developers actually deploying their APIs, which can be really good. But it does mean it kind of adds to that complexity of APIs now. Now they're not just web apps. Now they're something being managed by a third-party tool, and that third-party tool will have like its own considerations. But certainly for doing some of it, like things, whatever your authorization, your authentication, it does provide like a little checkbox. So Kong and MuleSoft, that kind of thing. But obviously it does add, and I'm sure if anyone here has worked with Kong or MuleSoft, you will know there is an added layer of complexity there when it comes to API. I want to make this really clear though, APIs are at their core just websites. Every typical web vulnerability applies to APIs, even client-side stuff like cross-site scripting. You know, the cross-site scripting, how does that payload end up in the database? Maybe they went through the API. APIs are still connected to both the like underlying database, the underlying backend, and the user interface, but it's just in a slightly different way. There are, of course, vulnerabilities that affect APIs to a much greater extent, though, like the OWASP API top 10, which we'll be talking about more next time. But in the meantime, if you guys have any questions, feel free to use the Q&A in Zoom, or you can use the Ask Me Anything on Mentimeter, which I think that is, or you can use the chat. I think this one is anonymous if you wanted to use Mentimeter. But if you do have any questions, feel free to throw them in. Though I do realize we're at time, so if you leave, I promise I will not be offended. So thank you very much, everybody, for being here and listening to me waffle on about APIs for an hour. Join us for our next one, of course. These are free sessions. They're just free API security training, because we at Traceable care about the security of every single API, whether or not you're a customer of Traceable or not. So I'm just going to go through questions again. Feel free to stick around if you would like to answer a question. Ask a question. But I'm just going to work through them. If you have a developer that says they have no documentation for their RESTful API, how would you learn about what the API does? That is such a good question. So this is really hard. The best thing you can do is to look at their code and see whether or not, especially if you're using a framework, there are some tools that can create open API specifications from like the raw code. I know there's one in Laravel because I used to be a Laravel developer, but you can essentially just run like a bot that will go through and like collect all the APIs and the API endpoints and like the parameters it needs and stuff. And that can be a really good first step. Then you just have to convince that developer to actually maintain it. That's the tricky part, and to actually build on that documentation. My number one like piece of advice for any security team is to go sit next to a developer and look over their shoulder and observe, like see how they work, and try and make you as the security team as uninvasive as you can for how they work. What are some tools like Veracode we can use as developers to test the security of our APIs? Really good question. Free tools, there's not a whole lot available. Obviously, there's like a few API security tools on the market. I think some of the best things you can do are using a tool called Authorize, or something very similar. I think there's a few different ones that can use cookies to automatically say whether or not an API is actually enforcing authorization or not. And that's a good place to start because that is the most common API security vulnerability. How do you transition from a developer to a security specialist like you did? That's a really good question. I never really intended to be a security expert. I was very much a developer. I went to university, I did computer science. I finished university, I was a Laravel developer, and I worked for a company making like a CRM software in Laravel. So I spent a lot of time looking at PHP and Laravel. I worked a lot with WordPress and JavaScript and a lot of that kind of thing as well. I was kind of like a jack of all trades developer. And I think it's hard to transition. To be honest, I very much got into security by accident. And when I talked to a lot of people who used to be developers, they kind of did the same thing. They kind of accidentally ended up in security. They kind of followed where their career took them, which isn't great advice because that's very specific. I would say it's about finding those opportunities to learn about security in your current role and be a developer who is a security expert, and then finagle your way into getting security training, and then having that kind of open discussion with your manager being like, yeah, I want to go into security, that's kind of my end goal, but I'm okay waiting and transitioning there naturally. It's very dependent on the company though, how much they like doing that. I think the best thing to do is take as many learning opportunities as you can and to always keep your mind open to possibilities. If I'm not a developer, how do I find out about all the APIs in my environment? You go speak to the developer and ask them very nicely to tell you. I wish I had better advice than that, but I really don't. You can use some fuzzing tools. There's a GraphQL word list called the only GraphQL word list you'll ever need. And there are a few API word lists and sec lists. And there's a tool called Kite Runner, which is like specifically for APIs. Those are the kind of tools I've had the most luck with, though I will say, yeah, it's hard. How a lot of products like Traceable work is we get deployed on like the server, and then we can see the requests and responses going between the API and or like what you're sending to the API, what the API is sending back. And then that's how we do that discovery. But certainly like that is, again, one slice of a much bigger pie. Are there any DevOps tools to perform security scans on APIs and make sure they remain secure after a change? No, very little. And I saw the question in DAST as well. API security testing is really hard, and that's because a lot of it is logic. A lot of it is based on things like my API like, should it has this kind of permission system, I shouldn't be able to do X, Y, and Z because it should stop me and it's not switched on properly. That's very much something that, one, would have to be dynamic, but two, that is really hard to tell the difference. And certainly when I start to talk next week about like next time about specific API security vulnerabilities, we'll see it in practice. But there's definitely a difficulty there, and there's kind of a gap as well. I mean, there's some paid tools as well. What's a good strategy for finding API security vulnerabilities? My advice is test for permission issues. They are everywhere. They're in every single API. Archangel D-Day has a really good way of explaining this, and he says he looks for no's. He looks in the documentation or where the application tells him that shouldn't be possible, and test to see if it is. That will get you much closer to finding a security vulnerability. I'm not gonna have time to answer all of these as well, by the way, folks. So if you do have more questions, do feel free to like reach out on LinkedIn or Twitter, and I will happily answer. What are the pros and cons of using API gateways from both a performance and security standpoints? Pro, it puts all the APIs in one place. Other pro, developers don't mind using them. Third pro, it gives you a sense of control that you actually have some of it like handled. The con, often it can give the illusion of security. You kind of need an API gateway and a security solution for full security. Gateways have really nice checkboxes, but checkboxes really don't represent the full depth of API security. And it's why like Traceable partners with API management solutions as well. Like we work with Kong, we work with MuleSoft, because we can provide like that one step further than what they do by default. Certainly, they do add to the complexity as well. As long as your developers are okay with it, if they're on board and you can keep them on board, it can be really useful because it does put it in one place. It does encourage them. However, it's a very different way of developing than they might be used to, and that can be really overwhelming for a development team. Especially I'll use myself as an example, right? I made RESTful APIs in Laravel using Laravel's default tools, and deploying something like Kong or MuleSoft is a huge burden on what was like initially a Control S kind of experience just to deploy them. And that's not right for every development team. And certainly if you're working within a smaller development team, or even a large development team that kind of has a little pods of developers working on individual features or projects, it does add a layer of complexity, and it might be an unnecessary layer. Probably have time for one more question. Is there ways to turn off throwing? Did you mean this query when providing gear? Not really, because it's based on the API itself, not you, that you can't do anything. It's the developers need to set it up. Are there any certifications that both teach you something useful and practical about API security and is valuable in the market? It's a really good question. There are definitely API security certifications. Like that is a thing that exists. I don't know about like valuable in the market, like something like an OSCP or like a SANS certification would be, and they tend to be web. So I would say anything that gives you web security skills would work for APIs, and I would hope and I think should be recognized. If it's not, it kind of sucks, but I personally think that should be recognized. That is unfortunately all I'm actually going to have time to answer today, because we're already 10 minutes over. Which apparently is 9 out of 9 though. So really, I've answered them all. Thank you so much, everybody, for being here today. I really appreciate the time you've given me, and for those that are still here, the extra 11 minutes you've given me. Please do sign up to the next episode. We'll be going more in depth about API security vulnerabilities, what they are, how to find them, how to defend against them, and how you can stop them, how they appear in the first place. So thank you so much, everyone, for being here. And I will see you in the next episode. Bye, everybody.